So in this one, we're going to look at how we can apply different rules of logarithms to do arithmetic, because just like exponents, logarithms have their own set of rules you have to use when doing arithmetic. So using the product rule is actually when I'm multiplying two values inside of one logarithm. So x times y in this case becomes the log of x plus the log of y. So this is an expansion. If I'm wanting to expand the logarithm, which might be helpful when solving, I can expand it by creating addition. So if I want to apply that to the given information, if I want to expand a, I can write it as the addition. If I want to condense b, I can rewrite that as the multiplication. In c, I have 8k, which is 8 times k. And if you notice, we can use a property here because the log of 8 and 8 are going to become 1. And the next one I have m squared. Remember that m squared is m times m. Using those expansion rules, I can write it as the sum. And then I can actually combine like terms with logarithms. So if I have the two situation where it says log base 5 of m plus log base 5 of m, I can combine those like I would with like terms. The quotient rule is going to be a similar feel because if I'm dividing two objects inside of a logarithm, I'm actually going to subtract them. So that way I'm actually expanding this out into a subtraction statement or condensing this down into a quotient rule. So if I have log base 7 of 9 over 4, that can be expanded into subtraction. In the next one, I have p minus log base 3 of q. I can condense that into division. And in C, I'm going to make that into an expansion, but I see 4 and 16, and I know that 16 is a power of 4. So I'm going to rewrite that as log base 4 of 4 squared. So the log base 4 and the 4 are going to cancel, and I'm going to be left with 2. Next, we're going to look at the power rule. The power rule says that if you have something raised to an exponent inside of a logarithm, you can bring the exponent to the front like you see at the bottom of the page. So if I have log base 3 of 5 squared, that 2 can move to the front of the logarithm. It's just a different way to write things that's going to help us with solving logarithmic equations. B is going to be the same property. I can bring that 4 to the front. Now in C, you have to stop and think, what is the square root of 8 as an exponent? Well, it's going to be 8 to the 1/2. Then I can bring the 1/2 to the front. In D, this can also be written as a rational exponent of x to the 4 over 7, where 4 over 7 can come to the front. So this is kind of an overview of the properties of logarithms. It's a really good idea to go ahead and copy this down onto a sheet of paper to leave it by your computer as you work with logarithm problems. It's great to reference this as you go through and solve, and the more you solve these, the less you're going to actually need that sheet of paper. So if I want to write an alternate form here of log base 6 of 36 times m to the 5th, the first thing I'm going to tackle is the expansion of 36 times m to the 5th. Once I've gotten here, I realize that 6 and 36 can both be written as powers of 6, and that 5 can come to the front. So when I write this log base 6 of 6 squared, the log base 6 and the 6 are going to be removed, and I'm left with the 2 from the exponent. Then I'm bringing the 5 to the front. In this case, I can write this as 9 to the 1/2 times z to the 1/2, which means I can expand that out by addition first, or I can bring the 1/2 to the front and then do the addition. The order of operations here isn't going to matter because you're going to get to the same place as long as you're carefully distributing values. I know that 9 could be written as 3 squared, but that's not really helpful to me because I can bring the 2 to the front, but I can't cancel out the log base 2 of 3 because they're unlike bases. I could then multiply 1/2 by 2, and I would get that fully simplified answer. So it's going to take some practice to get a feel for the best thing that you should do here. In C, I would go ahead and write that division as subtraction first. Then I'm going to go ahead and expand that 8 times r squared out. Next, I'm going to move any exponents to the front. Then in D, if I'm wanting to condense, the first thing I would do is bring those numbers in front up to the exponents. then I'm going to write that as a product. In E, I can't rewrite that. And the inclination is to go ahead and write that as 3x times y, but look at the difference here. It has to be the sum of two separate logarithms. It can't be the sum of what's inside of a logarithm. That's not possible to simplify. Now I'm going to be given some information, and I'm going to use the property of logs to evaluate each expression. If I have log base 2 of 25, I know that log base 2 of 5 is 2.312. So if I write that as 5 times 5, then I'm going to be able to make that log base 2 of 5 plus log base 2 of 5 using that log property, and I can add my sums together to get an answer. In B, I'm going to do something similar. I'm going to go ahead and write that quotient out as the difference, and then I'm going to replace it with the information I'm given in the problem. So notice we're not really using powers here. We're utilizing the product and the quotient rule. If I have log base 2 of 75, I know that 75 is 3 times 5 squared, which I can write as a product. I can bring the 2 to the front, then I can substitute in the problem to get the final answer. So there are some cases where you might be using an exponent, but you're not actually taking that 5 squared anywhere other than utilizing it to get it into the right form. Let's decide if this is true or false. So if I have subtraction, that becomes a quotient. Now, is this an equivalent statement to what's on the other side? Let's see. Okay, log base 6 of 30, I can't do anything to that to make it look like the left-hand side. Here, okay, I have a log inside of a log, so I'm going to have to take care of that first. So I get that 16 is a power of 2, it's 2 to the 4th. Now the log base 2 and the 2 are going to cancel, and that's going to be 4. Anytime you have the base and the inside is the same, it cancels again, and I get 1. Now on this side, I have the quotient of 2 logarithms. I can't do anything else as far as making that subtraction. But I can say that log base 6 of 6 is 1, because they're going to cancel. And log base 6 of 36 is going to be 6 squared, so I'm going to get 1/2. So these are not equivalent statements. In the lab, you're going to see examples of both the left and the right-hand side. So make sure you're paying attention there.